Could Good afternoon, good morning, everyone. Sorry, just a little technical difficulties here. So thank you for joining our webinar series today. And just quick introduction of who we have here. Myself, I'm Darius Fadinelli, and I'll be the moderator for today's session. I'll also be answering any questions you might have. Our trainer today is Eric Larson. He's a senior trainer here for Altair and has been in this position for about 8 years. I think you'll enjoy his session and his style, how he does the training. So let's go over a few notes before we get started. As you can see, everybody's in mute mode, and that is done for a couple of reasons. One, we are going to be recording a session, and we would like to have the sound quality as high as possible. And we've also found out in the past, many times there's a lot of background noise on somebody's speaker, so we just mute everybody to get the best quality sound for the recording. Everybody will be getting a link to this session, so at the end we'll be sending this out to anybody that has registered. If you do have any questions during the session, feel free to use the question tab and type in your question, and I will get back to it if it's something urgent, or we'll get back to it at the end of the session. At the end of today's session, we do have two very short polling questions we'd like to ask everybody and get your feedback. One will be is if you would like to get more information or more training about this topic for yourself and your team. And the second question will be is we would like to offer these sessions and some additional ones in the future for your next year build, and we want to find out when will be the best time to do it. So we'll be asking what month will be good for future sessions like these. So I hope you stick around to the end to answer those for us, and I know you'll enjoy today's session. So I'm going to switch over to Eric so he can take over. So just give us 1 second here.
Okay. Can you hear me? Excellent. Okay, good morning, good afternoon, and good evening. I think we've got all of the different time zones covered here. So I'll cover them all with a good morning, good afternoon, good evening. My name is Eric Larson. Hopefully I am showing my screen here. Let me just check. I can see my plane there. Okay, so I have been asked to talk to all of you about HyperMesh and HyperView and the capabilities we have in these softwares. Now this is just a quick 1 hour presentation. So this isn't going to be a formal training. You're not going to walk out of here knowing how to use the software, but what I want to do is just kind of present the capabilities of what we can do within the software, let you know that these things are available, and then allow you to pursue other ways of getting fully educated on the software if you find it interesting to you. You can always contact us through the Altair University website, and we have a tremendous amount of resources available for you to download for some personal training, online training along all those things. HyperMesh is a great tool that can help you guys out. So let me bring it up, and we'll talk about what HyperMesh is capable of. So this is, well, it used to be a maximize screen. There we go. So that is HyperMesh. When you first run HyperMesh, this is what you're going to see. And the reason I'm showing you this is because I want to bring your attention to this user profiles window right here. HyperMesh is a universal preprocessor. And when I say universal, I mean truly universal. HyperMesh can preprocess an analysis for any solver that exists or will exist. In fact, if you are the intrepid sort and you decide you want to go out tonight and write yourself your own solver code, HyperMesh can be a preprocessor for it. It does so through the use of what we call templates, which is kind of just a translation dictionary between the standard things in FE, elements, loads, properties, materials. All of those things just need to be translated in a language that your solver expects. So out of the box, HyperMesh supports all of the commercially available softwares. I'm sure you've heard of some, if not most, or possibly all of these. Abacus, OptiStruct, Radios, Dyna, Nastran. Out of the box, we support all of these, and we can set up an analysis equally well for any of these solvers. So don't let the solver that you're using be a stopping block in getting your hands on HyperMesh and using it. It is without doubt the premier meshing and geometry handling preprocessing software out there, and we can set up an analysis no matter what type of analysis you're doing and no matter what solver you're going to be doing it on. Now, we are quite fond of OptiStruct, as that is our software, so I'm going to load into the OptiStruct user interface. And what I want to do is just kind of give you an overview of what we can do with HyperMesh, some of the capabilities that we have. And I've got a few demonstration models here that I'm going to open up and just show you some of the aspects of HyperMesh's capabilities and the power that it has. So I'm going to go into Webinar here, and I'm going to open up this little model right here. So this is a fun and interesting model of a propeller engine here. And let me just quickly shade that. And you can see that this is a geometry model, came in from CAD system. I have no idea what. But the nice thing about HyperMesh is we support direct import from all of the major CAD systems there. So if you come here and we look under Import Geometry, you'll see a list of all the CAD systems that you're familiar with, CATIA, UG, SolidWorks. We support intermediate languages like IGES, and Parasolid. So any CAD package that you have, we can bring in the geometry from it, either in a excuse me, either in a native CAD format or in one of the intermediate CAD formats. So I've got this geometry here, and ultimately my goal is to mesh this geometry. I want to create a mesh for an analysis. But where HyperMesh truly excels is even before the meshing realm of, or the meshing capabilities, we have the ability to deal with the geometry. Now, if you've ever brought geometry into any other software, whether it's another CAD package or an FE package, you know that issues can arise in the translation. It's just a fact of life. It's unavoidable. It's going to happen. But HyperMesh has some amazing tools to help you deal with those issues and resolve them really quickly. So I've got a model here, and this model actually was in good shape, so I messed it up a little bit just for fun. So let me just isolate this propeller here. You can see it's very easy to isolate things, zoom in on just the areas that we're concerned about. Also, let me get rid of those little points there. So looking at this, I can immediately tell that there's some sort of issue with the geometry. I'm missing a little surface here, but beyond that, I really don't know what's going on. So we have some visualization modes within HyperMesh that allow you to determine whether the geometry is in good shape and whether the geometry is capable of developing a good quality mesh, because obviously, ultimately, that's what we're here to do. So I can come to this topology view, and now HyperMesh is going to color my part by the edges and let us know whether edges are properly connected or whether there are some connectivity issues. And the power of geometry in HyperMesh is that if you resolve any connectivity issues in the geometry stage, there's absolutely no reason to ever be concerned about connectivity issues in the meshing of your part. So we're going to resolve these. We can see these color-coded edges here, these red edges, have some issues with them. We've got some tools to do this automatically, so I can come up to geometry. And while I'm coming up to this, I'm going to bring your attention to these pull-down menus here. These pull-down menus are really the new user to HyperMesh's best friend. They're the ability to get to all of the functionality within HyperMesh very quickly and very easily. So I just simply need to know what I want to do, and I can get there. I want to come to geometry. I want to edit, and what do I want to edit? I want to edit some surface edges here, and I want equivalence. I want to take these edges that aren't connected and connect them together. So I can come here and put in a tolerance and say just grab all of the displayed surfaces, and I'm going to connect them together. So now I can come over to here, and it took care of most of the problems here, but there are a few that need to be resolved manually, or I could up that tolerance. But let me show you, we've got some manual kind of tools here as well. So I'm going to bring this this tolerance up even further, and I can just grab that edge. You see it closes that up nicely, and grab this edge, it closes that up nicely, and now I've got this fairly complex missing surface, but HyperMesh can take care of that as well. Just create a surface, spline filler, and I just click on one of these edges and it automatically fills it in. And now in a matter of seconds or minutes here, I've managed to fix the geometry issues with this part. I could take this and work in it in a surface, or within HyperMesh, it's very easy to create a brand new solid. So I just come here to Geometry, Create Solids, Bounding Surfaces. Grab that, it automatically selects all the surfaces, and now I've got a solid part here. And I can manipulate this solid part. I could trim it up, I could mesh it, I could do whatever I want with it. Now, let me just come back here, because that just kind of touches on what the geometry capabilities are. Again, I'm not going to teach you in these few minutes that we have all of the capabilities, but we have many resources to learn how to do these things within HyperMesh, so I am kind of going through a little quick here. But ultimately, we want to put a mesh on this part, so let me bring the rest of my geometry back. And I'm going to just quickly get rid of that, and I want to isolate this right here. So this is a solid part, and what I want to show you is we can do 2D meshing, we can do 3D meshing, 3D meshing, we can do brick meshing, we can do tetra meshing, whatever you want to do. It's very easy to do within HyperMesh. So creating mesh, I can come up here to my mesh, create 2D auto mesh. I just simply give it a mesh size, pick the surface I want to mesh, click mesh. I can see immediately that that mesh size is a little bit too big, so I can change that, remesh it there. Develop a pattern that I'm happy with, so I could come and adjust accordingly. Let me bring this up and bring that up a little further and up a little further. So you can see I could adjust densities on the edges of my mesh and on these as well, and mesh, and then play around with some of these numbers further and adjust the mesh however I want to get the quality that I'm looking for. So it's easy to create a 2D mesh. I can also very easily create a 3D mesh. If I want to come here to mesh, create solid map. Solid map is our tool for sure. Yeah. I can come here and I can do the solid meshing. So I can grab this and again give it an element size, click mesh, and it will develop a solid mesh here. So meshing in 2D, meshing in 3D. A request I had was to show a couple of the different meshing techniques that we have here. So let me come back to my 2D mesh. I'm going to grab that surface again. I'm not even going to delete the old mesh that was there. I'm just going to leave that on. HyperMesh has the ability, or has one of its core abilities, is to always relate a surface mesh to the geometry that it was created from, so that I never have to delete a mesh. I just can remesh it again. And I can do a mixed mesh. I can force a quad only mesh on there. You can see things have gone a little bit strange with that, so let me change the size. This doesn't perhaps lend itself ideally to a quad only mesh, but I could manipulate this geometry to make it work nicely. That wouldn't be overly hard to do, but I can also do a tria mesh if I'm looking to, say, have a pattern for a tetrahedral mesh, or if I was just looking for trias in general, so I can put a tria mesh on there. And I also have the ability to do an R tria mesh, right tria mesh. So that's a quad mesh that's split down the diagonal. So all of these different meshing techniques are available to me, and I also have geometry editing tools. So I can come here and say, split this surface right here and right here and right here and right here. And what this is going to do is it's now going to give me some control over my part, so I can improve the quality of the mesh that I'm putting on there. It now deals with both of these surfaces separately. And if I want to come back to my quad only, you can see now as I adjust this pattern, I can manipulate this. I can adjust the densities across these edges here and get a better quality mesh. So with a little bit of work and maybe a couple of other trims, I can manipulate that and get a very good quality mesh. In this case, though, probably the best bet is going to be going with a mixed. And we'll come down. We can even come down a little further with smaller element size. And you can see I can get a very good quality mesh here. So we have these tools available to adjust or to create whatever type of mesh we want, to adjust the quality of that mesh. We can do so in the meshing panel. We can do so in geometry. And also, so that's 2D meshing and 3D brick meshing. Let me turn on all of my components again. And I'm going to come back and I'm going to isolate my propeller. So now this is a part that if I wanted to do a solid mesh on this, and I wanted that to be a solid mapped mesh or a brick hexapenta mesh, if I could do it at all, it would take a fair amount of time to do. So this may lend itself better to a tetrahedral mesh, which is another strength that that HyperMesh has. I can come in here, say mesh, create tetra mesh. I pick my part, I give it an element size, I click mesh. I realize that, whoa, that element size is way too big, so I can come down on my my element size here. We'll say mesh with an element size of 1. Take a little bit longer to mesh because it's going to create more elements, but you can see even with the smaller element size, it's not going to take an undue amount of time to create this mesh on there, and you're going to see it's a pretty good quality tetrahedral mesh. Now I've meshed with a relatively small element size, and you can see it's a fairly good quality mesh. But as we all know, or if you know about FE elements, tetrahedral elements can be a very expensive element. There's many of them. If we up it to a second order element, it's going to have even more nodes. So oftentimes we want to not just mesh with a very small element. We want to be able to adjust the size of the mesh depending upon the features on the geometry. And of course, HyperMesh has that capability to recognize curvature and proximity in my part. So now I can come here and I can say, okay, mesh with a large element size, potentially come down to a smaller element size in areas of high curvature, and now I can not overburden my part with an extraordinary number of elements. I can get large elements in areas where large elements are acceptable, and smaller elements where I have high curvature. And you can see that now I've kind of messed up this edge. So it's just a matter of rejecting it, maybe picking a slightly smaller size, picking a different break angle, which is how it determines when it needs to go to a smaller element size. And you'll see in just a matter of seconds here that I can get a much better quality mesh, again, without too much effort going into it and still varying the element size to guarantee that I'm not overburdening my analysis. So you can see now I have an excellent quality mesh. Very large elements in the big central area, but smaller elements very nicely capturing that the curvature on that blade tip there. So we've got some very robust meshing tools, no matter what you're looking to do, whether you're looking to do 2D meshing, 3D meshing, tetrahedral meshing, anything along those lines, we've got the tools to handle it. Now, one of the other capabilities, and one of the perhaps lesser known capabilities, but very powerful tools within HyperMesh is our morphing capability. So oftentimes we've got a mesh, we've got something created. We could even have a model that's ready to analyze, and we want to make some minor adjustments to it. It happens all the time. I've got this solid block of elements here, and someday somebody comes along and says, hey, you know what? We no longer want it to be a perfect block. We want it to conform to the curvature of this surface here. Now, normally that would require completely remodeling the part, bringing into HyperMesh, remeshing it, setting up any properties, materials, loads, anything you had set up already. But with morphing, you're going to see here very easily, I can select the elements that I want to be able to morph. And tell it I want to map this now to a surface. So I want to grab that surface. I want this face to conform to the surface, and I want it to go in the x-axis, and I click auto mapping, and you can see now I've morphed my elements to match that, that geometry. And then if suddenly I say, okay, that's great, I want it to map to this geometry, but I want a little bit of a clearance, I can use some of the other morphing tools we have in here, which allow me to grab these handles and grab this little manipulator and just tweak it up a little bit, and now I conform to that cross-section, and I have a little bit of clearance there as well. Now, morphing is a tool in and of itself. It's a full day class to just kind of touch on what the capabilities are. Obviously, I've just shown it to you in about 3 minutes here, so this is just a quick, brief demonstration of the capabilities, but there are some tremendous abilities to manipulate your model, to alter your model, and the best thing is, because it's not remeshing the part, because it's keeping all the elements and all the nodes that were there are still there, I never have to worry about resetting up the analysis. If it was ready to run before I morphed it, it's ready to run after I morphed it. Now I bring in another model here and show you our capabilities for setting up a model for analysis. So this is a model that was set up actually in LS-DYNA. Chose this specifically just because not everyone's going to use our solvers. Not everyone's a user of OptStruct and Radios. So any of the solvers that are out there, we can set up an analysis for. So this is a part or a truck that's set up for an impact analysis. And just to show you what the capabilities of HyperMesh are to set up these analyses, let me just come over here to the materials, and I'm going to grab one. And in this entity editor we have right here, you'll see all of the properties of the materials. The Young's modulus right here, if I needed to make a quick change to that, I could just come here. Instead of 22,000, I'll make it 23,000, and now I've adjusted that material. If I have a property here, we'll come to a section shell, and I've got a thickness on this property. I can just come to that thickness, and now I want this to be 4 millimeters instead of 3 millimeters, and I can edit it right there. So all of the things that make up our model, all of the elements, all of the properties, all the materials, they're right here in this this browser. We have immediate access to them in this this entity editor format here, so we can get a very high-level view of our model. I can even come and color my part by the type of material that it's made out of, so I can do a quick visual check to make sure that everything is assigned to material properly, or a property view to make sure that everything is assigned to property properly. So HyperMesh is a great tool for setting up an analysis no matter what your solver. All the information is right there at your fingertips, very easy to create and edit. So like I said, this was just scratching the surface of what HyperMesh is capable of. Please do visit our Altair University website to see what it's capable of. And to get some more information, to get some more personal education tools that we have, you can go through some online classes. But this was a HyperMesh and HyperView introduction, so we're not quite done yet. What I want to do is I want to take this model right here. It's been run in Dyna, and now I want to come to HyperView and take a look at how we can post-process this model and the capabilities we have in HyperView and our HyperWorks desktop post-processing environment. So give it a second here while it comes up. This is HyperView. And in HyperView, all I need to do is point my software to the result files from the analysis, click Apply, and now here is the analysis run on that very truck. Let me slow this down so it doesn't go into hyperspeed there. So I can now see that impact analysis that was set up on that truck. And of course, I'm just viewing the video of it, but if I want to see things like von Mises stress, I can see von Mises stress. I can slow this down so I can kind of get a grip of what's going on here. I can put the mesh lines in there. I can see that. I can average these results. So as opposed to a single result on every element, now I get bands of stress, and I can see what's going on there. If I want to see what's happening on this hood, this rigid barrier is in the way, so it's just a matter of right-clicking on that, making that go away, and I can now see what's going on there. If I want to see what's happening inside the model, I can create a section cut, a cross section, and see that. And if I come to that section cut, I can say that I don't want it to be just a cross section. I want it to be what we call a cutting plane, and now I can see inside the model. And I can even take information from my model. So say, for instance, I'm interested in the distance from here. Oops, not there. Where's the distance? There it is. Sorry, I clicked the wrong button. Add the distance. So I want to know the distance from this node to this node in this impact. And if I'm in the cab of this vehicle during the impact, that's a very important number to me. And you'll see now I've got that distance, and that distance updates as it runs through the analysis. So I can pull information not directly specified by the solver, a distance I can measure off of there. Now, just reading that is very difficult, so I can incorporate HyperGraph into this. HyperGraph is our graphing tool. I click OK, and you can see now it's going to generate a plot of that measurement. So we have all of these post-processing tools available to us. We have HyperView to view animations. We have HyperGraph to create graphs, and those graphs can be created separately, or they can be pulled directly from data within our model. And I can even now come and split this into 3 windows. I can come to this window here, open up HyperMesh in this window, and give that a second. And when the HyperMesh window's open, I can open up the model, the FE model that was used to create this analysis. Make sure it's in Dyna because that's what it was done in. And let me just quickly open up that truck model. And let me fit this window here, and I can synchronize these windows so that I can directly compare my pre-processed model to my post-processed results. So I have a direct link between these two, or a direct visual link between these two. And I can always come back here, animate this model, and get this information. So HyperMesh, HyperView, HyperGraph, all of the tools that we have work together. They can pull data from each other. They can create incredibly precise pre-processed models that you can send to any solver that's out there. And then using HyperView, we can pull that data from the solver, and we can review it. We can get information from it. We can create our own results from it. We can create an entire post-processed report that can be presented in PowerPoint, that can be printed out, that can be turned in for an assignment, whatever you want to do with it. And in fact, HyperGraph, let me pop another window into here. HyperGraph is so powerful. I can use it independently. I can pull in a file from an FE result, and generate a graph from it, or if I even had just XY data. Many students that I've taught have started using HyperGraph even outside of FE just to create graphs for their classes because it was easier and far more powerful than using Excel or any of the other tools that are out there. And with HyperGraph, I can create single graphs. I can create multiple graphs and have it automatically sort and organize them. I can even perform mathematical functions on these graphs. So all the tools that we have, HyperMesh for pre-processing, HyperView for post-processing, in combination with HyperGraph in the HyperWorks desktop environment, can help you out, can allow you to do your projects, do your jobs, do whatever you're looking to do with it easier, quicker, and more powerfully than any of the other pre, post, and solving softwares out there. So like I said, this was just a quick view of what we have. There are many utilities, or there's many resources available to self-educate or to get in on a class. We offer classes around the country. Contact us. We can always look to get you into one and see what we can do to help you out. So I'm going to kind of open things up here for any questions, see if there's any questions that have been posted in the chat window that I can address. Or if we have any live questions, we can have you raise your hand and we can unmute you and you can ask it, and we'll devote the rest of the time that we have here to answering your questions.
Okay, we'll first go with the question that is being asked right now, Eric. Does HyperMesh have meshing specifically for composites, layering, non-isotropic material property definitions, etc.?
Yeah, so we do have some very powerful composite tools. What we can do is using property composites, we can create multi-layer, multi-orientation composite layups. We've recently, within the past few years, moved to a ply-based modeling system so that we can create composites in FE in the exact same way that we'd create them on the shop floor, indicating their material properties for each one of the different angles, indicating the angles, indicating the shape of that particular ply, and then laying them up in a laminate and doing analysis on them. Along those lines, and I'll bring it back up again in more detail on, what am I back on, Wednesday? No, Thursday. During the OptiStruct presentation, we can even do optimization on those composites. So we can create a composite layup and have OptiStruct optimize it for us, tell us the shape and the number of plies of each angle to achieve whatever goal you're doing. So yes, the short answer is we fully support composite layups, have some incredibly powerful and easy to use tools to not only create them, but also optimize them.
Great. Next question. Where can I find element properties such as reduced / full integration formulation?
So that would be solver dependent. If you go to, let me come to HyperMesh here. Let me minimize this. So when, depending upon the solver that you're using, each solver is going to have a number of different element formulations. And from any of the meshing panels here, we have this element types. And then I can come to the 2D and 3D and specify the type I want to create. Now in OptiStruct we only have a shell, but I think Abacus has a reduced integration, if I'm correct. So I can come here and come to element types, 2D, and you can see now I have all of these different element formulations that I can choose as the default formulation for each of these different types of elements. So I would change it for the quad 4 and the tria 3. I'm sure one of these, in fact I'm guessing that if there's an R in there, it's probably a reduced integration. I'm not intimately familiar with Abacus, so I don't know for certain, but this, if that's what the element type you're looking for. But if you come to any of these, you'd be able to pick the specific element formulation that you'd want, and I know many of them are reduced integration. So HyperMesh by default will use whatever the most commonly used element type is, but by going to the element types, we can easily select any of the other varieties.
Also, for certain solvers, the property cards also indicate.
Absolutely. Yeah, so as Darius mentioned, when I create property, in here, in this property, there would be options for reduced integration if that were one of the options in the property card. So in this case, we're choosing what type of integration we want. And now with this thickness, I can indicate the number of integration points across the thickness. So be it the element formulation or the property, we can fully cover any of the different element types that you're looking to analyze with.
The next question is actually a perfect question here. It was asked, I'm a student and I would like to learn HyperMesh and HyperView. What is offered for our students to get a copy of this software?
Absolutely excellent question. Fortunately, we have a student version of the software. It is available if you go to was it altairuniversity.com and you select from there. In fact, I think I probably can even go to there from here. So let me put this here, and I'll say altairuniversity.com. And you come to the academic program. You can grab the free student edition right here. You can order it now. It is free. You have to order it, but it's free. What it will do is it will ask you for your MAC address of your computer, and it will give you instructions as to how to get that. You include that in the order, and then it will you will receive a download link as well as a year license file to use the software. This is a fully functional version of the software, and I can't stress that enough. This has all of the functionality of HyperMesh. The limitation comes in, it can only be used with our OptiStruct solver, or I think Radios too, but definitely OptiStruct, and it has a 10,000 node limitation, and of course you have to agree to use it strictly for academic purposes, non-commercial purposes. But it is a fully functional version of the software. So go to altairuniversity.com and order it.
And also for those, so you don't have to remember different websites, if you go to our normal website under the Academia tab, it'll get you to that point too. So you don't have to remember one more website. We have another great question here for you, Eric. Tetra mesh elements tend to be expensive, as you said, overly stiff. Would it be possible to mesh to power quad/brick? Could you give it that little?
Yes, absolutely. So we have the capability of doing brick and quad. So let me get see what I can get up here.
Also, like to add that if you go to the second order tetra mesh, it would be less stiff, and that's an option too.
Yes, let me grab this right here. Do I have any geometry on this? No, I want to come to model. Here we go. And model view, component. I don't have any geometry on that. Let me see if I can grab something real quick that has geometry that I don't have to clean up. See if I can grab this right here. And I'll come to this, and let me shade this. There we go. And I will remove this. No, that's the absolute not one I wanted to. Bring that back. Let me turn everything on. And we'll right-click on that, and then we isolate this component right here. Okay, so, and now let me just mask this away. Solids, there we go, mask. Okay, so this right here, let me take and I'm going to trim this, and I'm going to mesh part of it with solids and mesh part of it with tetrahedral elements. So I'm going to just come to my geometry, and I'll do a solid edit, trim of the plane. I'm going to grab this solid, and I'm going to trim it with a plane normal to the x-axis, and we'll just trim it right there and trim. And now what I'm going to say is, okay, because of this little feature up here at the top, I want this upper portion to be meshed with tetrahedral elements, but the bottom portion, since it's a very simple surface, or solid, I want that meshed with hexa elements. So I just come to my mesh, and I'm going to create a solid map, and I'll grab that solid, say element size of 2. That's probably a little large. We'll go element size of 1, recalc all, mesh, and I have a very nice quality mesh there. Now, as you said, TETs are an expensive element. And they are stiff, and we've got a couple of options when we want to resolve the stiffness. The first of which, as I briefly mentioned and Darius had brought up again, we always have the option of going to a second-order tetrahedral element. For those of you not familiar with second-order tetrahedral, take your standard 4-noded tet and put an extra node at the midpoint of every single edge, and you make a tet 10, which completely resolves the stiffness issue, but of course now makes it an even more expensive element. So there's trade-offs here and there. But that being said, the question was, can I mesh tetrahedral, kind of a hybrid mesh between solids and tets? Absolutely. I just now come here to my mesh, create tetra mesh, and to transition from a quad to a tet, what I need to do is come here and say mixed. And what this will do now is if I select this and I give it an element size of 1 and I click mesh, it will put my elements in here, except it went and put them into the wrong, there we go, put them into the wrong component, but that's okay. So now I have my hybrid mesh, my tets and my solids hexes mixed together. But you'll see, and I'm just going to come here to this mask panel. The mask panel is great because I can isolate things by the type of element that they are. I'm going to come to 3D and I'm going to isolate my pyramid elements, and you see what it's done is it's created this layer that joins the solid hex mesh to the solid tet mesh. So the transition from a hexahedral mesh to a tetrahedral mesh are these pyramid elements, and as long as your solver supports them, we can very easily mesh them and allow you to create a hybrid mesh that's definitely not as expensive as a full-on tetrahedral mesh.
Great, thank you, Eric. Next question is, does HyperMesh support ply-by-ply solid modeling or coarse stiffened laminates to predict through this thickness effect?
Well, my answer to that is I don't know. Contrary to popular belief, unfortunately, I don't know everything about HyperMesh, but that is absolutely an answer that we can get you. What I would suggest is if you go to the Altair University site, we have a blog on there. Was it called a blog or a panel or forum? Forum, that's what it's called. I'm not up on these fancy internet terms. Forum where you can post your questions and we can get you an answer to that. I apologize. I know a fair amount about composites within HyperMesh, but that's a little bit beyond my realm of knowledge. So.
Okay, great, and also that'll give them an opportunity to use the forum there and see that they will get their answers from there too. Next question. When I create a load collector and create loads and boundary conditions, I do not know how to see clearly which loads and boundaries conditions are associated with that load collector. Is there an easy way to do this?
Yeah, so if you come to, I don't have anything with a load on here, so let me just unmask this. And so when I have a load collector, by default it creates it as gray, but I always like to color my load collectors, especially when I have multiple ones in my model, because right off the bat, coloring the load collector allows you to distinguish between one and the other. But let me come here and I'm just going to create, we'll create some forces, and I'm going to select that node there, and I'm going to say nodes by face, so I'll grab all the nodes on that face, and I'll just create some forces in the x-axis, and we'll create those and reject, and let me flip that the other way, -10. Create. Okay, so I have those forces there. So, and now if I come and I create another load collector, and I give this a different color, and I create it on the same nodes, but say I create it, and I'll say nodes by face, and this time I'll create it in the y-axis and create. So now I can see immediately that I have these two separate load collectors just by color alone. But let's say, for instance, and I'll create a separate load collector, and we'll make this one, we'll make it red. And again, I'll select nodes by face, But now what I want to do is I want it to be in the x-axis because I want to study perhaps two different levels of loading on that x-axis. So I'll make this one -20, and I'll create it. And just so it makes it difficult to see, I'll make them all uniform size. So now I don't see I have 3. The colors have failed me in this case because I have 2 exact copies of loads on top of each other. And what I can do, of course, is turn these on or off manually. But if I definitely just want to find out what loads or constraints are in this load collector right here, I just right-click on that and say isolate. And now it will turn off all of the other loads, and all I'm seeing are the loads that are in this load collector alone. So I know that this is the load collector that carries these. So I have the visual check of the colors. If the colors don't work, I have the ability to turn them on and off individually. Or if that doesn't work, I can always right-click on one and say isolate. Now, to save on what potentially may be an upcoming question, the difference between isolate and isolate only. So let me turn all of these loads back on. Now watch what happens here. If I right-click on this and I say isolate, it isolates those loads. And if I had 100 different load collectors in here, it would isolate this one single load collector and turn all the rest of them off. But you notice my elements are still there. Now let me do the same thing again. I'm going to right-click on this and say isolate only. Now, isolate only literally turns off everything else in the model except for the thing that I'm saying isolate only. So in the case of these loads, it turns off everything but the loads. If I were on a component and I did isolate only, it would turn off everything but the surfaces and the elements that are in that component. Isolate works within each little section here. Isolate only works across the entire model browser. So hopefully that answered your question on how to identify what's in what load collector.
Great, Eric. Another question came in. Actually, has 2 parts. I'll go over the first part. Does HyperMesh have a tool for simplifying assembly modeling, such as automatic contact interface detection?
Yes, we do have auto contact. Now you're trying my ability here to find that. Is it under Contact Manager? Let me see here. Nope, sorry, I don't want to be in. Let me come back up here to top destruct. And actually, that reminds me, there's something else I want to show you, which is our basic FEA profile, which can do it. There it is, auto contact right there. So I select auto contact. I indicate the type of contact that I want, slide, stick, freeze, or friction. I indicate the components and the proximity distance, and it will automatically generate contact between them. And before we move on to the next part of your question, one more thing I want to introduce here, because I really didn't talk about it, but it's a great tool for simplifying the FE process. If you come to our user profile here, and you change from HyperMesh to Basic FEA. Basic FEA is a simplified strategic view in HyperMesh. It still is using HyperMesh, but it tries to take and make the whole process of running an FEA easier and quicker. It isolates all of your components automatically. It allows you to mesh things in the background easily. It allows you to very quickly set up, and unfortunately there's a ton of components in this, so it's going to be a little bit slow here, but it allows you to automatically set up common types of analyses, and it automatically allows you to establish contacts using that auto contact between anything that is touching. So take a look at the basic FEA profile. You just kind of do it in a step-by-step. You start up here, you set your environment settings, you set your model, the type of material that it's made out of, establish a load step, or establish a load, and then create the type of load step you want, whether it's linear static, modal, buckling, sliding contact, or fatigue, and you can very easily run an analysis and even post-process it right within HyperMesh or post-process it in HyperView. So take a look at the basic FEA profile. It's a great way of quickly running an app.
Eric, I also believe that on the academic site you have a 2-hour video about the this interface, and also there are some tutorials about the basic FEA setting too, so to go through that. But again, it's made made to be like a wizard, step by step, to help simplify this, because we know that as a student you're not using HyperMesh or some of the other products all the time, and this allows it to be a little bit easier. So let's jump to the second question here. It's actually a request. Can you also briefly show the use of some of the context setting, which I guess you kind of went over a little bit. The key is that also the solver has to support the context
right.
too.
So yeah, if I come back here to HyperMesh and I establish the contact, once I have that contact established, I can come into the model browser. So let me just do this. Let me turn everything back on. I know we're kind of running a little tight on time here, but I think I can do this pretty quickly. So I've got. Let me turn this off. Oh, but of course my. There we go. And where is the mesh in my other part here? Oh, probably got deleted. Okay, so let me just come here and say 3D solid map. Multi-solid, grab this. Okay, good. So I've got a mesh there. So if I want to create a contact here, tool, auto contact, create a stick, I'll grab this component and that component right there. Find. I didn't find the component. Oh, maybe proximity distance wasn't enough. Doesn't it like? Let me see why it's not. I thought I grabbed both of these components. Okay, this maybe it doesn't like it because this is because it was generated off the same solid. But the short answer is once you create the contact, you'll have the contact in here. You just click on it, and you'll have all of the properties for that contact down here that you can go through and edit. In Hyper or in OptiStruct, if you come to the help documentation, HyperWorks help home and go to solvers, you can get the values for the contact in there. You can get the values of the card or the fields for the card and find out what each of them does and allow you to edit them accordingly. So all of the information conveniently is in this entity editor that you can work with in there.
Okay, we have last two questions. After these, we'll have to stop. So the next question is, speaking of contact, will HyperMesh resolve a press fit?
Resolve a press fit. Yeah, I haven't worked with press fits. I know we have pre-tensioning capabilities, and I've heard of press fit analyses. Again, that's something that's a little bit outside of my knowledge base, so that's something we'll probably have to point you to the forum to talk to somebody about to elaborate a little bit more on the forum. The forum is moderated by Altair employees, and they'll pop in and answer. But it also is a freely open forum, and many times you'll find that the questions that you ask will be answered by other students who are getting onto the forum. So it's a free forum that allows conversation back and forth, not only between you and Altair, but between other students who are experiencing things as well. So that would be another question you're going to have to ask in the forum there.
Great, thank you, Eric. Last question. Is it possible to control and modify a model through scripting with HyperMesh and OptiStruct?
So yeah, and I unfortunately am not a scripter. I have seen scripts that have been written by people at Altair and by customers, and they just absolutely amaze me. But the short answer is HyperMesh uses TCL/TK as its interface language. And all of the things that you've seen me do here in HyperMesh, there is an API written to do them. And those APIs can be accessed from a script. And if you know scripting, you can pretty much automate just about any function that you want to in HyperMesh, and using batching, you can even batch it out to other to say OptiStruct. So you can have it automatically do things within HyperMesh and then create the FEM file and batch that out to OptiStruct. So the short answer is absolutely. Just about anything you can want to do can be automated within HyperMesh. We do conduct webinars, I think quarterly, for customization of HyperMesh that cover scripting. Additionally, there are resources that you can look into. It does use the standard TCL/TK language with specialized APIs built within HyperMesh to access the HyperMesh functionality. So.
Yeah. Also, to that point is on our website we have our portal, and if you go in there and sign up, you can access what we call the script exchange, and there's about 1,000+ scripts that have been developed by mostly Altair AEs out in the field, but also users that hit a lot of specific scenarios in there, and then so they have things that can help simplify certain things. So feel free to do a search on that, and maybe there's some additional things there. But like you said, interacting between HyperMesh and OptiStruct, that is possible, but it sounds like a very custom need. So depending on the use case that you have, it might be something that has to be done specifically for that. So, and as Eric said, we offer that class usually quarterly online. Well, we're pretty much out of time, but we would like to go to the 2 polling questions. So let's, if you can make me back the presenter, Eric. And and if you can please answer these 2 short questions here. So just waiting for my screen to come up. But now for the polls. So the first, actually, I'm just trying to get into the polls. Somehow it's not showing me our 2 questions here. Hold on 1 second, please. Maybe Ryan, you need to come in and okay. All right, great. There we go. Now so the first one is thank you. You see it on there. And yeah, so and what we'd like to do with this is for your team for further training, it'd be optimal for us to hit your team, provide training for them, or if you're a university department, so if you're part of the ME department and you would like to get some additional training, or to see if it can be added into your curriculum, like change over some existing courses that your classes do have, we'll be more than happy to help out with that. So we'll just let this be open for about 5 more seconds here, and then we're going to close this and go on to the second question. And thank you everybody who have answered that one. So now on to the second question. We know we're late in the cycle for maybe these topics affect your current design. What we'd like to do is offer these and some additional topics. Like for instance, we have a very user-friendly tool called Virtual Wind Tunnel that can probably be helpful with understanding a little bit more of what's going on for the CFD analysis for your car. But again, that's too late to do for this design. So we'd like to provide these and other courses at the appropriate time, and if you can identify which works best for you. And so a few more people that maybe can vote, or if you're not sure, we understand that too. So about 10 more seconds here, and then we'll close that poll. Excellent. Thank you so much, everybody, for answering the 2 polling questions. We do hope you enjoyed today's session, and I know, as Eric has said, that we scratched the surface of things here, and that was really the intent, to see, so you can see what some of the power is behind the pre- and post-processing tools that HyperWorks have, and if it's of interest and you think it can help you out, that you can contact us to, arrange a more detailed training class, visit your university, if possible, too, and get you set up there. So again, we do appreciate your time, and feel free to also attend the other sessions that we have. On this Thursday, we have the OptiStruct for structural analysis and optimization that also Eric will be doing. And then next Tuesday, April 7th, we'll have the OptiStruct for composite analysis and optimization. And the following Thursday, which is April 9th, we'll have the Inspire for conceptual level design generation. All great classes, and hope to see you guys there. Have a great afternoon, everybody.